All right, good morning, everyone. Welcome to the second day of 2026 CEDAR workshop. It's wonderful to see many of you here. We have a very full schedule today, so in the interest of time, we will just get started. Today, we are pleased to have our agency update session, where we will hear about the updates from our agency representatives from NSF, NASA, ONR, and NOAA. A lot has happened in the past year, and we are looking forward to hearing the updates, the changes, and the priorities from our agencies, and the impacts that these developments have on our CEDAR community. To ensure that we have enough time to get to all of the agency representative talks, we will keep the Q&A at the end, but please use the Slido. I want to show the Slido QR code. Can we show the QR code for Slido? Yes, that one. So please use that anytime that you have a question to submit your questions. We will get to the questions at the very end. And I would really like to encourage our students and early careers to participate and submit questions. This is our chance to interact with our agency representatives. Without further ado, I would like to invite Shikar Zada to talk about NSF updates for us. Thank you.
Yeah, good morning, everyone. I'm really excited and delighted to be here today in person. This has been a long time for me since I attended this meeting. I did virtually last year, and prior to that, I had an accident, so I couldn't attend. So I'm really, really excited and delighted to meet all of you. So I'm currently managing aeronomy program and CEDAR-related activities at NSF. And before I begin, I would like to acknowledge the PIs and co-PIs, Dr. Hannah and Lean. They have been very helpful. And also the logistics team, Tracy Baldwin, as well as Rebecca and Jessica Martinez. And of course, many thanks to CSCC Chair, Lynn Harvey, and all other committee members. So yeah, let me. So here is the agenda. I will be talking about the current staffing at NSF, and followed by some program highlights and current budget situation, and present some priorities and NSF funding opportunities. So as you all know, NSF has undergone several changes. There has been reorganization. AGS is no exception. So we have our new directorate head, Jyodeep Kundu, who is leading the GEOS directorate, followed by Anna Johansson, who is now deputy directorate head. She was earlier division director for AGS, and now she has been promoted because there are no divisions any longer, and we have moved to sections. You all met Dr. Shri Sharma yesterday, who is our section head and overseeing AGS-related activities, which includes lower atmospheric as well as geospace-related activities. So we currently have 4 program officers that are responsible for geospace-related programs. So Andreas is responsible for, let me put the pointer. Yeah, so Andreas, no. It's okay, I'll do it without pointer, no worries. So I clicked here.
Yeah.
Yeah. Oh, yeah, it came, yeah, thanks. So Andreas is responsible for STR and MAC programs. Alina Petino has moved from EAR, Earth and Atmospheric Research Area, and she's managing geospace facilities. So while she settles down, I'm also helping her out and is still managing some of the ISR facilities. Mangla Sharma, you probably know her very well. She has been responsible for space weather-related portfolio within AGS, and I already mentioned about my responsibilities, so I will move on to the next slide. So this slide basically shows like workshops that have been funded through AGS program. Um, the importance of workshop is recognized by NSF. It allows people to come together and interact, provides new networking opportunities. So CEDAR is one example. Apart from that, NSF has funded Steve and Hamsai, like partially funded these workshop which have like citizen science component, as well as provided travel support to enable US scientists and participate so that they can participate at ICA 17 symposium. So thanks to all the PIs who took this initiative and organized these workshops that allowed all these networking opportunities to our community. So now I will show some program highlights. One of the important programs at NSF is Faculty Development in Geospace Sciences, which is FDSS, and through this program, NSF has contributed over $20 million and have allowed early careers in leadership roles. And this program was initiated in 2004. So since then, about 23 FDSS hires have been added to our community. So the recent hires are shown here. So if you are one of the recent FDSS hires, can you please stand up? So no one is there. I think they are busy. So yeah, anyway, congratulations. If you know, please give my regards and congratulations from NSF for their hard work. So I will move to the next slide. So as you all know, research infrastructure plays a very important role in advancing science and technology, and especially to geospace that are relevant to geospace research community. Our community has been very resourceful, and they have leveraged MRI awards, which is NSF-wide competition. And one of the MRI awards was awarded to Mark Honde from UAF, University of Alaska at Fairbanks. So this, through this award, the team was allowed to develop a tri-static network of instruments in Europe so that they can perform new, they can obtain new observations along with ISCAT 3D facility when it becomes fully operational. So this work has led to the deployment of 3 containers in Europe, and these containers, they house several optical instruments as well as GNSS receivers along with magnetometers. So another MRI award went to Fabiano Rodriguez at UTD, and this allowed, this will enhance the observational capabilities of Hikamarka Radio Observatory, and this is a collaborative effort between Dave Heisel, Koki Chow, Danny Saipion, Marco Milla, and Kenneth Hobenberger. So Fabiano, who is here, congratulations to you. You have done excellent work. And he shared some photos about the recent development. So they are going to develop antennas arrays close to JRO, one at Huancayo and one at Santa Maria. So this will enhance the field of view of Hikamarka, and if you want to learn more about it, please contact either Dave or Fabiano. So another MRI award went to John Merriweather and Andrew Garrett from NJIT. So they have successfully acquired and tested a system which is like a state-of-the-art FPI instrument from Kio Scientific, and it will allow high-resolution wind and temperature measurements at 3 different altitudes. So John actually recently communicated to me that the system is ready for deployment. Let's hope and see new results later on. And the last MRI award, which is the recent one, was led by an early career, Vishnu Kumar, along with Rich Collins and Rodwick, who is an engineer and early career engineer. So this has promoted collaborations with the laser industry and has resulted in the development of 2 Relay Me Raman LiDAR. One is deployed already at Poker Flat and collecting data, and other one is at HARP. So now I will present like some geospace facilities. So AGS is supporting the facilities that are shown here on this slide. As I already mentioned, Lena Patino is our new program officer for geospace facilities. And Dave yesterday mentioned in his talk that Hikamarka is undergoing several upgrades. Many of the upgrades have already been finished, and that is also true for Millstone Hill. So these upgrades will allow new observation capabilities and enhance the life of these ground-based facilities that are very crucial for scientific work that our community is doing. Recently, Millstone Hill PI, Larissa, informed me that their system, Meteor Radar and GNSS receivers in the close proximity of Millstone Hill, they have recorded this huge meteor Cape Cod Bay event that occurred on 30th May. And the team has already analyzed and actually written a paper. So they are going to discuss results in Thursday's session on meteor work. So if you're interested in learning more about this event, please go to that session. And another program highlight is DAISY. So DAISY has been like very important in adding small scale instruments that benefits our community. So there have been like 2 solicitations so far, and NSF has contributed over $15 million through this effort. So 4 recent DAISY awards to our community are shown on this slide. They are basically extension of the previous work that our community has been doing. So now I will present some science highlights. So before I describe these science highlights, I would like to mention that all the PIs here, NSF-funded PIs, are doing excellent work. So if your work is not mentioned in this presentation, it doesn't mean that you are not doing important work. So please don't be discouraged. If you have been supported by NSF, it means like you are considered deemed worthy of support and you are doing excellent work. So again, because of time restrictions, I'm just showing some highlights that are event-based or are have been published recently. So the first one is by Shivaji Chakravarti, who is an early career at Embry-Riddle, and this work resulted from an NSF aeronomy grant. So it allowed the team to study the ionospheric G condition, where like the F2 region densities, they actually become less than F1 densities. So if you want to learn more about this, please refer to this paper. And this ionospheric condition results because of diffusion processes and also because of some chemistry. So the next highlight has been shared by Kathleen Greer from LASP, and this work resulted from an aeronomy grant, and the team has investigated the impacts of strong polar vortex on the ionospheric variability. So the previous work has focused on weak polar vortex. So this is one of the initial first studies that is studying this kind of event, and the preliminary work has shown that the electron densities can vary by about 60%, and they also exhibit some longitudinal differences because of this strong polar vortex. And the other science highlight resulted from a recent CEDAR science grant. So it was to Toshi Nishimura. And the team has studied like the effects of geomagnetic storms on GPS position error. So there were 2 papers. The first paper is led by his grad student, and the second paper is led by his postdoc. So this is an excellent example like of mentorship. So congratulations to Toshi for training the next generation of scientists. And this work actually, because of its impact on agricultural industry, it was highlighted as an NSF news article, and this has been published on the NSF website. So if you're interested in learning more about this science, I encourage you to visit NSF website as shown on this slide. Now I will discuss one of the important national priorities, that is artificial intelligence. So NSF GEO also has took initiative and provided some funding opportunities that encourage collaboration in AI and geosciences, that is CAGE. And I'm pleased to announce that one of our PIs, Professor Josh Sameter, congratulations to him and his team. They successfully won this award, CAGE Award, and the aim of this work is to combine optical and GNSS data sets along with AI and machine-based learning techniques, as well as provide training opportunities to early careers to advance the understanding of MI coupling. So now I will present some news about the budget. You might already be familiar about this. So the President's budget request for the next fiscal year is shown in the upper table. So as you can see, the enacted budget for this fiscal year is about $8.8 billion. And the change for the next fiscal year is going to be less by about 54.7%. And this is substantial reduction. So this is not only going to affect, if implemented, of course, these are just like Congress has to approve it, but like we have to prepare for the worst case scenarios. So NSF was asked to prepare like the budget for each directorate, and the lower table shows what is the response of Geo Directorate for this budget request. So research is going to be affected and reduced by about 65.4%. Education will be impacted and reduced by about 83.7%. And infrastructure is going to be reduced by about 50%. So this is like not very encouraging. However, I again say that these are just projections and things may change, so we should not lose hope. And this is the funding scenario over the last few years, our funding rates. So GEO's funding rate is showed by orange line, and blue represents the NSF funding rate over the last few years. As you can see, because of the budget uncertainties, the funding rate has gone down, and if this trend continues, it does not look very promising. However, we can leverage the other new funding opportunities that may be made available to our community, which I will discuss in next few slides. So GEO was about 24% last year, the funding rate, basically. So yeah, it's very important because of these changes that we align our research activities to current administration priorities. And some of the priorities are, NSF priorities are listed here. So as you know, AI and emphasis on data centers and application to industry, commercialization, these are some of the important things that our administration is going towards these changes. They are also promoting translational research, which means how well we can apply our fundamental research and commercialize it and take advantage of partnerships with private industry and other sectors. GEO also organized a workshop which brought quantum information scientists and geoscientists together at Stony Brook University with the aim of promoting collaborations among these communities. Coming to geo priorities, so geo priorities are similar to NSF priorities. However, they include some extra things like space weather related work, especially their prediction capabilities, and national security operations and work that promotes like national security strategies, development of technologies that allow our community to develop societal resilience and develop like tools and techniques to mitigate the impacts of natural hazards. So these are some funding opportunities that are currently available through Geospace, NSF website. You can learn more about it. Geospace core program accepts proposal throughout the year. And then there is CEDAR and sign solicitation with the target dates listed on this slide. Apart from these opportunities, there are NSF-wide opportunities. So one of them, which our community can benefit from, is Eclipse program. So through this program, this program supports proposals that are relevant to plasma science and engineering. So I think this is something which our community can really leverage and can align their proposals so that they can, take advantage of this opportunity. So if you want to submit a proposal to Eclipse program, I strongly recommend that you visit the website, the Cognizant program officers listed on the website. Please feel free to contact them if you have any questions. And then there are other opportunities that have certain restrictions, like MCA and career programs. You can visit, again, website for more details. And then there are some opportunities that are led by SICE Directorate. One is CSSI, which is like cyber infrastructure for sustained innovation, for sustained scientific innovation. And it has deadline in December. So this has you still have some time if you want to consider submitting proposal to this opportunity. Please refer to the website, and then there is data-related opportunities, that is IDSS. And again, for Tech Access, AI Ready America, this is something like a very big program. It involves collaboration at a state level because it intends to develop coordination hubs. And it promotes work that will translate AI that has application to industry. Then there is another one, which is Translation to Practice, NSF-TTP program, which is NSF-wide opportunity, and this is something very important that our community can really leverage. So I'm very pleased to announce that Professor Maurice Cohen, is he around? No. So he's from Georgia Tech, and he has successfully leveraged NSF-TTP program and taken his agronomy research to another level and obtained about $1.1 million and is partnering with Vaisala Incorporated. The team is planning to develop global maps of tea region using VLF techniques. So as part of this collaboration, Vaisala Incorporated is going to develop some technology licensing. So what I'm saying is these are some funding opportunities that provide more funding that our community can leverage in coming future. So please pay attention to these opportunities and learn more about this. The websites have webinars. I encourage you to contact Cognizant program officers before you submit a proposal so that they are aware of your interests. So yeah, I would like to end my talk by quoting Albert Einstein. We all are going through very tough time and challenging situation. So I really like this quote, which says the measure of intelligence is the ability to change. So thank you again for your attention.
Thank you very much for these comprehensive updates that you provided.
No, thank you for giving me the opportunity.
It's great to have you here. It's great to have NASA people here, because last year I remember we didn't have anyone in person. So it is great. Thank you so much for being here. All right, so we now move on to our updates from NASA Heliophysics, and we are pleased to have Nikki Rail and John McCormick to give their updates.
Thank you very much. Awesome. Good morning. I'm Nikki Rail. I'm so pleased, as you just heard, we're so pleased to be here this year. It's a big change from last year. I'm glad we can be here in person to have conversations in the hallway and to be here to share some updates. Today, John and I will be sharing this presentation, and I'm happy to kind of talk about what's been going on at NASA headquarters across our portfolio. So today we're going to give a few updates, talk a little bit about some of the strategic initiatives we've got working on, space weather, and then John will be transitioning to talk about our research program realignment. and look forward to taking questions, I believe, at the end of all the speakers today. So I just want to share our family photo. This is our pit crew. We have a few additional members of our team here, sitting right there from headquarters with Sias Shume, Jared Leesner, and Denise Hill, in addition to John and myself, and I see Doug over there from Goddard. So we're really pleased to be here and be talking with you. And it's been a challenging time. We've been really focused on our mission to enable science and how we can best enable your activities together. We do see shifts coming in the way we're going to be doing business, and we look forward to the future of that and also trying to figure out how we maximize on our science return in light of the changes that we've all experienced and been navigating the last few years, and how we are going to work together to do things a bit differently from the past recent years. So what have we been doing? And what quick snapshot of what's been going on in 2025. 2025 was a crazy year. It was a rock star year. We had 7 missions launched, of which were 13 spacecraft and 1 instrument. We had 10 sounding rocket campaigns that involved 17 rockets, and we had 3 CubeSats deployed. It was an incredible feat of our team, of the community, of all the PIs that came together, and the development teams that worked this. I am so proud and thankful for everyone that was involved in getting all of these missions literally off the ground. And it was just, a tremendous feat of effort in a very dynamic time. All the while this was going on, we were in the midst of Solar Max with over 400 solar flares, including almost 20 X-class flares, and a huge G4 storm that happened. So it was an incredible time, not only for our discipline area, but for getting real-time views of a really active time with Solar Max. And was really exciting. And just thank you all for your contribution to our ability to be successful. It was a rock star year. So we were really lucky to announce some new SMECs, some of our small explorer selections. We have our Cinema mission that is proceeding into phase B. That's our cross-scale investigation of Earth's magnetotail and aurora, with the PI being Robin Millen from Dartmouth. Really excited to see that moving. And we also selected CMAX into extended phase A. So they'll have a little bit more time to do a concept study, and Holly Gilbert is the PI from NCAR. Looking forward to moving down the road with both of those missions and working towards launch with our Cinema mission. So excited that heliophysics is a real word now. I know so many of you work tirelessly to help contribute to making this happen. Having it defined, having our discipline defined and be something that is an actual word is incredible. Thank you all for your efforts in making that happen. I was personally really excited to see this and look forward to more of a common nomenclature around the term heliophysics and how it describes and encompasses so many of the disciplines that everyone supports. All right, so moving a little bit further forward in time, since we haven't been here in a while, we're sharing a bit of a big update today, but from 2026 now, it's also been a busy year. Haven't had as many launches as we did in 2025, but we have had a really busy period with our sounding rockets. So BADASS and NICE, I think best acronym ever. We actually weren't allowed to put that acronym in our press release materials. Don't get me in trouble for saying it here. We had to spell it out and people use their wits to formulate the acronym. But we've had really good success. We've had PIs happy with the data. We've had a report of that the Lattice receiving sites were successful, and really looking forward to kind of seeing more as we work towards publication of the information. These went from Poker Flat in Alaska and launched right into Aurora, which is an absolutely beautiful image. In addition to our sounding rockets, we also have kind of a CubeSat and SmallSat portfolio, and all of these missions really demonstrate the scrappy, fast-to-flight, really efficient science, rapid turnover, and development of our instrument and payload teams. We see a lot of early careers coming out of this area. We see people growing project managers, and it's just an incredible area. I personally love seeing you can design the science, implement the science, and get the data back in a time span that's much shorter than we can with our orbital flight missions. And our sounding rocket portfolio is just a shining example of where we can go with rapid, high return on investment science. And I'm really thankful for everyone involved in that portfolio. All right, so we also had a pretty exciting year with Artemis and everything that's been going on. The Artemis II launch, My background is actually in human spaceflight and the biological effects of spaceflight on the human body and organisms. And so personally, to be able to see this and to see our astronauts launch and return safely is incredible. More importantly, though, heliophysics and space weather have such huge impacts on what we're doing to protect our human crew. It's really been tremendous. So building up to Artemis testbed exercises with our Moon to Mars and Space Weather Applications Office, and how we collaborate with NOAA and the Space Weather Prediction Center, as well as our Space Radiation Analysis Group. All of these groups get together to make sure that we, number one, are understanding the complexities of the environment that people are launching into so we can better predict what might be happening, but also how we can prepare for future exploration missions with our human space travelers. And so, we had a little bit of an exciting event with a solar flare happening right before launch. Because everybody boots on the ground was able to come together and do analysis real time and understand what the impacts would be, they were still able to continue with launch. But it just demonstrates, in Solar Max, you never know what's going to happen when you're putting humans and not just a robotic mission up. It's a whole different kind of dynamic. But NOAA and NASA and the Moon to Mars office all working together to ensure that that human crew was going to be safe was first and foremost. And, the sun kept it exciting with a few days to go for that mission launch. Another recent kind of success story is our AWE mission, which launched on the space station in 2023. This instrument was incredible because it's studying atmospheric gravity waves, connecting them to real-time observations, taking many images of the night sky view. AWE did its job. It went up, it went on the station, it was operated for a little bit longer than its planned lifetime, and it's now coming down. But real kudos to this team. They were also able to observe Helene, some severe weather going on while they were up there, and connect that to what they were seeing with atmospheric energy. And I'm just really happy to see AWE performing as it should, and now we're returning it back to the ground and on to the next one. But AWE was a great example of, it defined its science, it completed its science, and then it's returning back to Earth off of the space station. So very exciting last week. I see Amy sitting somewhat in front of me. We were very happy to announce a selection under our dynamic mission solicitation, the Daphne mission, with the PI, Dr. Amy Merkel, and a few of the folks that worked tirelessly to make this selection happen are also sitting at the table over there. But Daphne is incredible with his multi-point measurements of neutral winds, temperature, and composition in the thermosphere. We're going to get information to help really connect space weather predictive capabilities with what's going on in the lower atmosphere. I'm thrilled that we were able to make the selection on this. I know it's been a really long time coming. Thank you for your patience and perseverance. We are thrilled that this mission is going forward into its next phase of development, and really look forward to working with Amy and her team on the development of the activity. And a big congratulations to Amy. So just want to share a few things of what's coming up for us after looking back in the rearview mirror a bit. So we have our Sunrise mission, which is developed out of the Jet Propulsion Laboratory in Southern California, or JPL. We have 6 toaster-sized CubeSats with solar radio that will be observing solar radio wavelengths. They're going to orbit within 6 miles of each other above the Earth's atmosphere, and they're going to function as a single aperture radio telescope. So we're really hoping to gain more insight into what's going on with space weather and how geomagnetic storms are generated. So we're really considering this as a key enabling function for enabling future forecasting and helping protect astronauts and our space assets. We also have Sunset, a CubeSat launching in 2026. The Solar Corona Ejection Tracker is a 6U CubeSat. And we also have Cubix, which is going to be an X-ray solar spectrometer. So those are 2 more coming up, as well as WinCube, another 6U CubeSat. And it's really amazing what we're seeing out of these CubeSats, the really strategic science activities that they can conduct. They're low-cost, high-risk missions in most cases, and the science return has been phenomenal, and we look forward to the launch of those upcoming missions. Did want to share a little bit about some of the things we've been thinking about strategically within the heliophysics division. So science is our foundation, society is our customer. What does that mean? Everything we do, the reason we exist is here to enable science. It's our bedrock, but the American people as our customers also are part of our important stakeholder chain, and how we enable science, how we conduct science so that it benefits them, while also staying true to what the important and key foundational science activities that we need to complete are. So we really, I think, feel strongly that science is an incredible and compelling reason for us to be doing our work. Enabling incredible discoveries, and then also enabling incredible applications from those. Many times they go hand in hand. There's many serendipitous applications that come out of science, and there's also ways that if we think about how we address our foundational and translational science and put it together in the beginning, we can actually kind of enable these applications for society as our customer. What does that mean? Some of our missions, we can add, added benefit of putting on space weather instruments and make sure we're protecting infrastructure, satellites, and key technology. Others lead to incredible discoveries that not only address their scientific goals, but also increase key applications for our stakeholder community, the American people. So our portfolio is varied. One discipline is very well represented here, but we have many, many different disciplines within our flight portfolio and our ground portfolio. One thing that is important to note is that space weather kind of is a common thread that weaves through all of these disciplines. We will have, solar physics, we'll have MAG, we'll have ITM, all of those important disciplines, and there is a thread that reaches and touches our space weather portfolio as an underpinning for the rest of our foundational science. And we see that there is no independent line for space weather, because space weather is influenced and impacted by all of the disciplines within the portfolio, and we appreciate your contribution to space weather as a whole across our portfolio. So operating missions, we have a tremendous fleet within our Heliophysics System Observatory. We're really lucky 24/7 to be capturing data from all different vantage points, from near Earth to inside the sun's atmosphere, all the way out into interstellar space. We have been collecting incredible data. Some missions have been up for as long as 50 years, others 20, others 10, others 15, and some newly launched as we talked about. But one thing that we're really paying attention right now to is how we make transitions between our prime science and our extended operations, and that there's kind of a planned ramp down in science funding as we transition between our prime science activities and our extended operations. The goal being that we clearly articulate that up front so there's no surprises from the PI team. And we're also in a position where we cannot keep every operating mission going in perpetuity. Many of them have been going north of 20 years, approaching the 30-year mark. It's incredible to have multiple solar cycles. We're really lucky to have that data, and how we can kind of strategically look across the portfolio and ensure that we keep a continuity of key data sets where we need it, but also make room for our new science, new missions like Daphne coming on board, and new missions called out in the decadal survey. And so we're working to address that now, and also trying to best understand how we can support our Heliophysics System Observatory as a whole. We really count on you, our community, as our voices, and how you're interacting with the stakeholder community. We appreciate you all working together as a community. Every PI working for their individual mission alone often comes at the detriment of the rest of our community, and we appreciate all of your efforts on how you've tried to rise the profile of the entire community, and hope to continue seeing you do that. So we have a few missions in development that I wanted to talk about. One is GDC, our Geospace Dynamics constellation. We're currently executing a GDC Trailblazer mission. So this mission is kind of a proof of concept with a subset of instruments from the original GDC Announcement of Opportunity, using ETUs, or engineering test units, that are already complete and already built. Trailblazer is going to be a rapid, highly commercial mission that demonstrates a path toward launching the remainder of the spacecraft. So we're doing this demonstration of what we can do utilizing a more commercial approach to then work towards a broader GDC campaign where we can enable the GDC broader science. Trailblazer by itself will not result in the full GDC science complement. It will not result in the full realization of the decadal survey science goals. However, it's a really important stepping stone. I'm thrilled that we're at a point where we're actually getting ready to plan launch of this GDC Trailblazer. Many of you have been involved in how we've defined concepts and what we've done and the ups and downs and the long storied saga of funding and no funding, but we're at a point now where we're going to be able to launch this trailblazer and really demonstrate what a future potential capability is using these commercial platforms and also then working to define a broader GDC science campaign. As far as our future announcements of opportunity, I can't share right now what we are actually going to be releasing and when. I'm sure, as you saw from our colleague from NSF, there's a lot of ups and downs and noise in the system. We're just going through the normal part of the budget process. Happens every year. Sometimes it's more exciting, sometimes less exciting. As we work through that process, we hope to be able to define when we'll be releasing announcements of opportunity and have more details around them. I can tell you a few things will look a little bit different. One is we're working to reduce the burden on proposers. We understand and have gotten many, I wouldn't say complaints, much feedback, but is really constructive on where we can ease the burden of the process on people proposing, and also what is going on behind the scenes on our end, which is a tremendous amount of paperwork and evaluation. So we're working to really be maximizing the key important parts of the process and getting rid of the ones that are not value added for either the proposer or for the review team. And the other thing is that our AOs are going to look a little bit different. They are going to be a little, more of a strategic focus. Our AOs, since they've existed, have been focused around decadal survey science goals. And, for the most part, that is not going to change. What you will see is a strategic focus, and you all are masterful at aligning your science goals and your science aims to what those focuses are, and that will be the same thing that occurs moving out in the future. So I wanted to spend just a little bit of time talking about space weather and how we connect our missions to a user benefit. Our heliophysics science missions return incredible science all the time, the data that's coming down. Some of them are also augmented in a fantastic way to also provide some space weather benefit. So we aren't changing the scope of the missions. We are often augmenting by things like, iAlert for IMAP or for Punch. We're getting data down and using it for an extended benefit. And so it's an incredible opportunity to not only realize the science from our missions, but for some augmentation and a little bit of extra instrumentation sometimes or extra ground stations, we're able to get an additional space weather benefit without diluting the original science goals and adding to the return that we're able to get from each mission. And really appreciate many of you have come up with some of the ideas that have helped with that benefit and how we've implemented the user benefit for space weather. And I just wanted to share how we think about space weather. Space weather sometimes is this abstract construct, but it's really practical, from the farmer in Iowa who can't get positional, GPS navigation to plant crops, or the humans traveling far from Earth that we need to ensure are protected from launch all the way through return, to emergency workers, airline pilots that make their flight plan and flight path dependent on what's going on with solar activity, and of course our active duty personnel that are serving in austere conditions all around the world that rely on radio and high frequency navigation and communication to be successful. This is how we think about space weather, is not just this abstract construct, but really how it impacts people here on Earth and also our exploration crew traveling far from Earth and more, doing that more so as we come up with more Artemis missions in the coming days. So we do put, of course, primary emphasis on what's going on with Artemis. Artemis is one of the key priorities for our entire agency. It's incredible that our community, our discipline is very critically important to enabling human exploration, both in the modeling side and in the prediction and monitoring. So we have folks, like I said, like the Space Radiation Analysis Group that are doing kind of the real-time radiation exposure and dose response. We have our Moon to Mars office helping us plan our trajectories and some of our orbital dynamics, as well as our launch and return times. We also have our biological and physical sciences sister division putting things up like avatar tissue chips, where they're putting tissue chips of human analogs so they can contextualize the biological response to what we're seeing with space weather. And we are fortunate that our discipline feeds directly into the space weather pipeline and enables human exploration in a major way. So we had some pretty cool events going on with Artemis. They saw this beautiful eclipse. Our human crew traveled farther from Earth than ever has been in the past, and it really just demonstrated the connection both of space weather with a real-time visualization of some eclipse activities, but also what was happening with solar activity right prior to launch. And I feel very fortunate to be working with my colleagues to help enable human exploration, but also to enable your science. That's why we're here, to enable science and keep our crew safe as they travel far from Earth, and really look forward to continuing to work with this community as we move out with missions like GDC and Dynamic that are going to bring down critical results for the community, as well as our future human spaceflight missions. And I'd love to turn it over to John now to talk a bit about our research portfolio.
Thanks, Nikki. So our research director, Teresa Moretto-Jorgensen, could not be here today, unfortunately, so you got me. But this is an important group to talk to, and I'm really excited to give you some updates on the current status of our research program and directions going forward. So we'll start with doing a sort of a by-the-numbers slide. For ROSES 24, there were 17 program elements solicited and 879 proposals submitted, 138 selected. You can see more of the details here. There's even a QR code to scan if you can down below. A couple of things I want to emphasize. The first is that we ran 90 panels and we had 534 panelists. The panelists are people from the community like you. And just a huge thank you if you served on a NASA review panel. We're very appreciative of your time and efforts. We need that, and a big thank you. Second, as you know, these are the ROSES 24 numbers. This is the last, the most current solicitation where everything's closed off and we can run the numbers. ROSES 25 is open now. ROSES 25 looked different. It was smaller for reasons you can probably understand. We are currently, I believe the LWS, the Living with a Star, Step 2 proposals, the due date was yesterday. We have ongoing reviews for the Heliophysics Foundational Research, HFR, solicitation. The Step 1s have been submitted. The Step 2, Step 1s are being reviewed now. Step 2 deadlines will be announced after that Step 1 review. We've got research to operations to research in the space weather program and Radiant, our AI solicitation going. So we are working through ROSES 25 solicitations and the reviews, and the big question, of course, is what about ROSES 26? Well, ROSES 25 is currently still ongoing, and we thought ROSES 26 was going to be released soon. I was hoping to come to meetings like this and talk to you about what's going to be in ROSES 26, but it's been delayed. We have a number of new processes being put in place regarding our solicitations. We're working through those. Those have caused delays. So at this time, I can't tell you when ROSES 26 is coming out, but we are working very hard to get it out as soon as we can. Nikki did a really nice job showing how heliophysics, as we know it, is really broad. It's interdisciplinary. It's system-wide. It's system science. I'm talking about the research program here, so you can think about it as maybe this one little piece of the pie. But what really the idea is that the science that you do, the research that we're undertaking, the science that's enabling exploration, if you want to think of it that way, is really part of a bigger picture. Of course, folks are doing the research that supports the development of the science concepts for large flagship missions that have been part of our STP and our Living with a Star programs, the Explorers programs, of course, for the PI-led investigations. Nikki emphasized the importance of space weather and our approach to space weather, and of course, the technology development through the sounding rockets, balloons, CubeSats program, all very important, all very big pieces. But what we're going to talk about here and where we're going with the research program is to not think so much about these as little individual pieces, but of course, as sort of one unified approach. That includes basic research, well, you could call it applied research or research that's sort of moving to the next step to developing predictive capabilities. Of course, incorporating end users to understand potential applications. And then actually that last part, the R to O to R part, where what you find out from the applications can fuel, more directions for future research. So in the spirit of that, what we're trying to do and what we're aiming to do is develop a research program that's going to be streamlined, that's going to be strategic, and it's going to be sustainable. And to that end, I want you to think a little bit about, well, how do we do that when we open up the next ROSES solicitation? And so again, we mentioned for ROSES 24 and earlier, we've had many program elements, 16, 18, 20 sometimes. And rather than having a large number of program elements addressing maybe what you might think as more individual pieces of the big puzzle or the big system, what we're trying to do now is be more strategic, more streamlined, and actually, rather than having sort of disciplinary silos where, well, this is, the work we're just going to be doing for this one discipline, identifying strategic objectives and goals and formulating our research program to certainly align with the NASA and the national priorities within those strategic objectives, but also move towards getting to science faster. And so, whereas in the past, you might have looked through ROSES and seen, well, there's a program element that's designed to study this area or this, perhaps special campaign, and of course, what we're trying to do now is sort of have this more integrated into that research to operate, sort of basic research, applied, and back programs. So we're certainly not saying don't be curious. We're not saying don't do the science as you normally do it, but we're sort of organizing it differently in a way that we think will be beneficial both for achieving the goals that we need to and making this, again, maybe a more supportive and sustainable enterprise. So with that, as I mentioned, we have the goals of simplifying and streamlining the structure of our program to enable innovative heliophysics research and modernize our approach, meaning, we've been doing the same thing for 20 years, perhaps. We can think about, is it time to sort of reorganize and optimize? So going forward, the elements in our RNA program will be organized really by strategic, results-driven objectives. And we're going to be focusing more on developing metrics for assessing performance and making sure as the research progresses in alignment with our overall strategy, we can point and say, yes, we're making progress. We're going to be emphasizing collaborative, longer-term research. It's not the only thing we're going to do, but we're going to be enabling more of that. And strengthening the connections between the different parts of that heliophysics portfolio I showed you. So the pie, instead of being one little piece of that pie, we're all sort of integrated together on a deeper level. So the benefits are, again, system level and interdisciplinary science. We've gotten to the point now where heliophysics, the problems that we have to address really are, I think, involving larger efforts and system-wide and system of systems type of approaches. We want to provide more opportunities for early and mid-career scientists to explore different roles and, of course, reduce the burden on the science community in terms of trying to get support. So these overarching strategic goals solve the fundamental mysteries of our sun and its domain. These are goals, okay. Build predictive foundation for Earth's space weather resilience, safeguard human exploration, and power a sustainable, secure, and data-driven orbital future. So again, these sort of line up into the understanding of how, in a broad sense, heliophysics will deliver benefits, not just to the agency, but to the nation. And so these objectives, to meet these goals, we've identified in the short term sort of the critical path, if you will. We want to investigate the physical drivers of thermospheric variability, cross-scale energy transfer and geospace response, the mechanics of solar eruptions and particle acceleration, and plasma interactions in the planetary environments. These are the four sort of critical objectives we want to address in the near term with the research program. And I'll note that these objectives map to the strategic mission concepts that were put forward in the last decadal survey. And so these are going to be sort of the foundation, if you will, of some of the research emphasis going forward. Additionally, what we've identified as sort of frontier objectives, or if you think about throwing the stick out even a little bit farther, or reaching for that extra effort, investigating the solar dynamo, the interstellar boundary, and of course, enabling cross-disciplinary discovery, the fact that interdisciplinary and system-level studies, such as the impact of solar variability on planetary atmospheres, something to sort of broaden heliophysics reach. And so we're going to be prioritizing larger teams and broad collaboration throughout the community. We're going to be aligning investments to results. And a term that's come up here, the integrated knowledge chain, I had to think about that one a little bit too. If you go back and think again about, I've done basic research, applied research, I've even transitioned some things to operations. Each step of the way, it's not easy. You want to actually ideally have people who are doing the transition step also have knowledge of what is going on in some, maybe even the basic and applied research areas. One of the challenges was always, well, what are your requirements? And people want to, on the other end, want to say, well, what are your capabilities? What can you actually do? Where are you pushing the science forward? So what we want to do is sort of have a more integrated approach where either users are involved, end users are involved in developing some of the research strategies from the beginning and vice versa. So rather than just, I know my one little part of heliophysics, we're getting together, we're getting people together to do the research and understanding from fundamental theory to final application through common program goals. Faster science, of course, and stability, providing longer, more stable awards to allow researchers to spend more time on discovery and less time on the proposal writing and reviewing. So in the time I have left, I'll just briefly go through the RNA themes that will be sort of guiding our program going forward. The first is preparation for space flight. This is to develop the scientific foundation for future space flight activities and explore future scientific directions. It can involve theoretical and analysis work needed to develop mission concepts and to make progress on closing knowledge gaps in preparation for space flight investigations, and of course, relevance to space weather and human exploration programs is always a key. RNA theme 2, RNA research and analysis program. We're going to have focused science objectives and foundational research. So if you're familiar with the HSR, HFR as we call it now, heliophysics supporting research, foundational research, the Living with the Stars science efforts, think of that as, in this theme, as we're exploring fundamental physical processes, integrating system-level science, developing the understanding that can eventually progress to predictive capabilities, achieving priority science with existing data and capabilities. Theme 3, strategic capabilities. Now, if you're familiar with the RNA program and Living with a Star, you know we had a Living with a Star strategic capabilities program that was very much dedicated to model development, following priorities laid out in earlier studies, sometimes from the decadal. And in this sense, this strategic capabilities theme sort of builds on that, but it's more than just models. It's recognizing the need for the tools, the products, and the systems to do the science. And so this is also in recognition of the fact that in the most recent decadal survey, the recognition for the need of a sustained effort for developing some of the larger either modeling or data assimilation or other computational tools that we need for this type of research, and to move it forward significantly and quickly, hopefully. So the fourth theme is rapid access to space. If you're familiar with our low-cost access to space, LCAS, the HFORT, CubeSat lines, also the technology development. This theme will sort of encompass this and will be with the goal of developing mature heliophysics technology and demonstrating it in space. Yeah, with the key on rapid. And finally, well, not finally, I got two more, sorry. Space weather applications, again, you're probably familiar with the R to O to R, the research to operations to research program in space weather. But we've also been running the Space Weather Centers of Excellence. And these two together sort of show both the challenges and the need for not only rapid transition of research capabilities to the operators who need it for space weather, but also the recognition that there are some big problems for space, or big questions for space weather research that need to be addressed with probably more sustained and larger efforts. And so RNA Theme 5, Space Weather Applications, will likely involve both of those. And of course, last but not least, and this is very important, is the workforce development. Theme 6, where we want to foster and support a healthy pipeline of scientists and future leaders for heliophysics. And so in the past, we've had early career programs, Finest through the Rosa's Appendix F and others. We'll be looking for innovative ways to develop and sustain a healthy workforce. Key takeaways: this structure prioritizes innovative strategic advances. We're building off of, in some sense, the success of existing approaches involving our Drive Science Centers, Space Weather Centers of Excellence, the Living with a Star focused science topic teams. So this idea of collaborative research. Progressing from, the program will sort of have a progression built into it from going from foundational research to applications, but focusing on the strategic big questions that we need to address. We want to introduce more opportunities for multidisciplinary, multi-method investigations. So again, think of sometimes these focused science topic teams or these centers of excellence where you're taking in people who mostly do observations, modeling, theory, integrating that into one type of investigation to, again, make significant progress on some of these key objectives that we've identified. And we'll be promoting what we call active portfolio management to drive the progress forward using science-based metrics for success. With that, we have a couple of announcements and lists of resources. So in the short time we have left, I'll turn it back over to Nikki.
Thank you, John. All right, just wanted to mention, if you weren't able to see our community meeting, you can use this QR code to relive the excitement and watch it with us again. And you heard a lot of common theme ideas today of what we presented there, but please check that out if you haven't had the opportunity. And also wanted to mention, we are thrilled that we have a Mars L1 workshop coming up. The NASA Space Weather Program is hosting this at NASA Ames Research Center. And just what John was talking about, how we involve, from forecasting to applications to science all together from the get-go in the same room to plan a future space weather mission to Mars using L1 as a vantage point. And then if you haven't already subscribed to our newsletter, here's the information to do so. We do try and send out regular updates and keep you posted on what's been going on both at headquarters and with our missions. Please join us on our newsletter. And lastly, I think we're taking questions later. So thank you very much for your time today. It's a pleasure to be here with you.
So you will come back later. All right, sounds good. Thank you very much. All right. It was a lot to digest. Thank you very much for going over all the amazing portfolio and also the realignment of the RNA program. It will be more smooth. So we also have updates from ONR. Bruce Fritz was scheduled to be here in person. Unfortunately, he wasn't able to join us either in person or virtual. He submitted a couple of slides and also submitted a statement. I will not read the whole statement, but just in the interest of time, I will highlight the most important thing. So this is basically the ONR General BAI. The QR, you can search with this number that is here and also the QR code to get to the main website. Here is a couple of bullets regarding the research that they are doing, which is basically focuses on the bottom side ionosphere specification and forecasting and also skywave propagation. There are, you can submit white papers. A lot of members of the community have already submitted white papers, and Bruce looks forward to continue working with all of you. So if you would like to submit a white paper, please reach out to him directly or go to the main website. This slide, I thought it was very interesting because it highlights an ONR Global X challenge. It's a special opportunity from Global X, ONR Global X, which is international outreach arm of ONR, and it has it's 6 proposals that offer groundbreaking methods for improving the analysis and forecast for the bottom side ionospheric electron density, both temporarily and spatially, with emphasis on southern latitudes. And please note that the proposing team needs to be led by an eligible non-US research entity. So for all of our colleagues are here from the Southern Hemisphere, you are eligible institution to submit to this. The US institution can be a co-I on that opportunity, and the white papers are due July 10th. And you can go to this, use this number to get, or this link to get more information about that if you like. And I think that is it for Bruce. So we thank Bruce for this update. I think this is very exciting. And with that, I think that brings us to the end of the agency representatives. We had on the schedule to have updates from AFOSR, but unfortunately the slides did not get approved in time, so we are not able to show them here. All right, so with that, we move on to the question and answer session of the program. So I would like our agency representatives to come here to join me in the panel table. And also Irfan, if you could stay online in case there are questions for you. Shika, would you like to come? All right, so I know that we have some questions on the Slido. Do we have any questions in the room that you would like to start, or we go from the Slido? Okay, so maybe we go from Slido to just break the ice.
Sorry about that. Yes, we have several questions in Slido. 2 of them are related, so I'm going to read the 2 of them together. The first one says, NASA seems to be moving towards larger, more collaborative teams for projects. This disadvantages early career folks and those that aren't as well networked. Given that grants are not keeping up with funding needs for senior folks to support graduate students and postdoc, how will you support? And then the related question is, adding larger programs to the portfolio is a positive development. However, if they replace smaller PI-led programs, the effect will be to channel even more resources to those who are already well-funded, making it harder for investigators from smaller institutions and more junior.
All right, thank you. Those are great questions. I will say there are pluses and minuses to every schema. We incorporated a lot of community feedback on smaller projects and complaints that wasn't working well, and that oftentimes it's the larger teams that are more funded, that are able to bring on more early career personnel. And so there are two sides to that coin, right? There is benefits to both approaches. Based on feedback and the strategic approach, I think we are trying to align around these larger teams and hoping to be able to incentivize participation by a broader swath of the community, and also more early career folks. And as John spoke about, having some targeted opportunities that are really focused on early career. I think there is no 100% right answer. We are definitely taking the feedback that we've received up to this point and trying to, we're very much attempting to, with these larger constructs, be able to have more stability in funding, which was a significant area of feedback of that the lack of stability in funding was a huge deterrent from people being able to maintain postdocs, maintain early careers. And so this is our response to that. We're going to try this experiment and hope to continue to receive feedback from you all in the community, and also hope that we are addressing some of the concerns that were previously raised. We can't do everything perfectly. We are sure trying to make our best effort to be beneficial in the stability of funding and how we're forming these team constructs, and look forward to your feedback as we roll out this new approach. John, do you have anything you want to add?
Yeah, I think with this shift, if you will, or this emphasis, we're not completely abandoning, smaller awards or things like that. But, I was lead for the Living with a Star science program for several years. Those were collaborative teams built together from sort of an individual award sort of put together. There really wasn't, it's one of the things we heard from that is that people wanted to assemble their own teams. And so this is sort of building off of some of that. The other thing is if you are proposing sort of a larger collaborative effort, there's nothing stopping those proposers from incorporating the younger or the early career development within that proposal. And it is going to be very important for communities like this, where there's either people who've had, or at a smaller institution, people at larger institutions, getting together within this community and developing collaborative approaches to propose, but also to address some of these big objectives that we're talking about. That can be part of how we go forward. So it's not necessarily an all or nothing, but it is a shift, and we're talking about this now to have people aware that there's going to be room for all this, but based on what we've received from the feedback, this is what we think is going to be most effective and most sustainable.
Following on that, then that means that eventually you will go back and evaluate how the program is working and see if it is meeting the necessities of the community then.
Well, I would rephrase that a little bit differently. We are going to be working very closely. We're going to be managing. We're going to be looking at metrics for success to make sure that they're addressing the objectives of our program. But obviously, the health and the vibrancy and the creativity of the community, maintaining that is obviously something we don't want to eliminate, or things like that. So we want to support that. But first and foremost, no, I mean, we have to be targeted. We have to be strategic in what we want our research to go. And we know, based on the past, that you folks can do that. But it's more of a refocusing.
Move on to the next question. May I ask you to put out the Slido QR code there so that people can ask questions? Great, thank you. All right, so let's try the room once more. Yes. Do we have any questions from the room?
I have one for NSF and one for NASA. Mike Wilberger from NCAR HAO. Shika, any updates that you can provide us on the current fiscal year plans for NSF in terms of grants coming out and activities on that front?
Some of the things are confidential, as you know. So we are waiting to see like the final budget numbers. So I cannot disclose like what proposals are like pending or some of the awards which were like, smaller. So they are already like supplements and which were like essential and were submitted like even in last fiscal year are now being processed. So we are holding some of the like decisions. So in case there is some funding that becomes available to us, then we will take decisions. So yeah, things are on hold right now. Sorry, I cannot add more than this.
Great, thanks for that update. And then, John, this one's probably a little down in the weeds for you, but looking in the NASA Rose's language, there was statements in there about charging for high-performance computing time on the awards, and biology is starting to do it, and heliophysics is thinking about doing it, having the accounting there. And the question is, how does that come into the cost cap for the awards? Because like for CGS, we burn probably an FTE worth of compute time to do the modeling work that we're on there, and that's a big impact on our ability to support other types of researchers. So thoughts about what that rollout's going to look like?
So yes, there has been discussion about charges for high-end computing. For fiscal year 27, our program is planning and budgeting to cover those costs so that they won't be passed on. I can't comment on what our plans are going to be in the future, but right now that's what we're planning on doing. So we are trying to budget that. And so it's like everything else, probably a bit of a rapidly, or, it could change. But for FY27, it should be something that we'll cover.
Thank you. Do we have other questions from the room? Come on, people. I'm sure you have a lot of questions.
We can ask one
All
more
right,
from
go
Slido.
ahead.
This is for Shika. Are there any updates for the CEDAR proposals that were recently submitted?
Yeah, as I mentioned earlier, some proposals are like already have been reviewed, and we are waiting for the final budget numbers. So I cannot provide more information than this because like there are so many budget restrictions this year, unfortunately, that is delaying actions.
Maybe he has that.
Oh, sorry. Is this better now?
Yes.
Yeah.
Yes.
Okay, thanks. Yeah, I was just saying that I mentioned earlier that there are a lot of budget restrictions, and proposals have been reviewed. We are like holding those proposals with us not declining because if some funds become available, we can make some decisions. But I cannot provide more information than this since there is so much of budget uncertainty. So that is delaying our actions. So yeah, I'm sorry that I do not have much information to share with you guys, but let's hope that things improve and we can make some like decisions that benefits all of you
Right.
in the near future.
Thank you, Shika. Mirs, please.
Hi, this is probably a question mostly for Shika. Many of us are engaged in updating libraries and large computational systems to use GPUs, to use more massively parallel systems. Would the cyber infrastructure or the Eclipse program be appropriate for doing that kind of work, or is that really meant for other kinds of?
No, I think cyber infrastructure is something that you can actually explore, and I highly recommend that you contact SAIS program directors who are like responsible for CSSI and IDSS opportunities. Eclipse program is more like science oriented. So you should look into like Eclipse program and like what are the budget caps. So based on that, you decide like how much is science and how much is like data intense, approach that you are going to use or utilize in your proposal. Again, please contact Slava Lukin at NSF for Eclipse program. And I think Mangla is representing Geo in that initiative. So you can contact either of them. Yeah, but if it is basically cyber infrastructure intensive, then I would recommend CSSI.
Thank you, Shika. Go ahead.
This is working. Hello? Yeah. I have a question for John. I'm wondering, in the step 1 and step 2s, is there a targeted selection rate? And what would the rationale for that split be?
So I wouldn't say that there's a targeted selection rate. And so the question is, just for some context, starting with Rosa's 25, most of the program elements have you submit a step 1 and a step 2, but there's a decisional step 1 process. So in the cases where we have a solicitation that's received a very large number of proposals, and remember, when you look at the solicitation, you can see at the last section of the NRA, the Rosa's write-up, expected funding, expected number of awards. If we're in a situation where we have just a huge number of step 1s, if we're oversubscribed, there will be this competitive step 1 down select process. We don't have necessarily targets for a selection rate per se. I mean, we're sort of moving away from, I think, selection rates, but a lot of it could be just how many proposals can we actually review and give a fair step 2 review. And recall the step 1s are about a 3-page or a 5-page. They're shorter. The step 2s are the full-blown things. Putting together step 2 proposals, huge. Well, it's a sizable investment in time and effort. So I think what we're trying to do is really balance what can we do programmatically. Because again, those step 2s, they have to be reviewed. They have to be reviewed by folks like you. They have to be reviewed thoroughly. Sometimes, we try to give you a month to review 4, 5, 6, maybe sometimes of these proposals. What's practical, what's doable, and what can we expect to fund? So it's not like we have to say there's going to be a hard rate, but there are programmatic constraints. Now, there is the possibility too, if a proposal or of a program element does not receive a huge number of step 1s, step 2s could be, so we're thinking about being flexible with that approach, but step 1, step 2. So I've tried to just add a little bit more, sort of context to your question, in that in this environment right now, we're receiving a huge number of proposals for a reduced number of program elements. How do we deal with that? And I think what we've heard, the feedback, and again, we're trying to refine this process as we go. We have actually heard some positive feedback from this process about, yes, it does kind of help. You're not investing as much of a time in the step 2s. So I hope that helps. It's not just a formula, and we are trying to develop the step 1 evaluation process to be as rigorous as it can within the constraints of a 3 or 5-page proposal and the turnaround time. We have to turn these step 1s around fairly quickly to give people time to prepare their step 2s, or if they weren't invited to go, to look at other opportunities. So I hope that helps.
Yeah, thank you.
Okay, so this is a question for NASA. So I heard that GDC is now like a trailblazer. So I know that the GDC is 2013 decadal survey, Living with Star mission. And for the 2024 decadal survey, there's a new recommended mission, LWS mission, that is for solar. It's monitor the sun's polar region. So my question is, will GDC still be a full mission, like in line? When there's money, it's going to be in the line before that Science Living with Star mission that is recommended in 2024, will that happen? You know, will it still in the line? Or it will be skipped?
So looking back to the 2024 decadal survey, there were kind of decision rules, and those rules for funding prioritize GDC and dynamic over new missions to complete the missions of record from the 2013 decadal survey. And so, of course, everything is dependent on out-year budgets, of which the process is still very much underway. But we see the Trailblazer and this year's appropriation, the FY26 appropriation that came through, affirming the importance of GDC and the implementation for FY26 of the Trailblazer mission as a great indication of the importance of the mission and our ability to move out and actually implement it. So it's hopefully not an either-or situation. We are following the decadal survey rules as far as the decision for budget available to go back to implementation of GDC and dynamic. GDC as a campaign and a broader science mission is very much dependent on out-year budgets, and we'll continue to work that as Congress releases what appropriation law looks like. But that's how we're thinking about it, making sure we follow the decadal survey while also hoping to enable the strategic missions that were detailed in the new decadal survey, and looking at maybe some new form factors. How can we do lower cost missions using constellations and use CubeSats and other things as a creative way to implement some of the science of the new missions, in particular, the LYNX mission, and we have solar polar. So there's both concepts are proceeding, and I said I hope it's not an either or scenario, but we're very happy that we have appropriation law in hand for this fiscal year to begin implementation of the Trailblazer for the GDC mission.
Okay, thank you.
Before I,
It was on.
sorry, before I ask my question, I want to thank you guys for being here in person and taking our questions. I really do appreciate that. But I do want to ask a little bit of a pointed question, and I want to make sure that you guys NASA comprehends the reason why there are so many proposals submitted to step one. Do you guys understand the forces that are causing us to submit so many proposals?
Yes. We don't live in a vacuum. We read the news just like you do. Yeah. But we have to deal with those. They're submitted to us. We have to take them in. We have to evaluate them. That's our job. That's our duty, and we're trying to do that the best we can. So we understand.
Michael Berger again. One piece of commentary from the community that I'm hearing for feedback on you as we're all trying to navigate this new step one, step two process at NASA. We're on the community side are trying to figure out what works in a step one process. And the feedback coming back from the evaluations has been pretty limited for people. And so as you think about what's going into the review, pathways to get more information back to PIs so they know what to make a successful step one and they can get their ideas through that pathway, I think would be a valuable improvement to the process.
So thank you. Yes, that is something we're working on. I would say that's important for step one and step two. I have always tried to emphasize that when a proposer gets back a review, that they understand and that there should be useful feedback, selected or not. But that is one of our challenges. Do we find, for example, for reviewing step one, do we try to get a large number of reviewers to go over that, which is a challenge, or do we find smaller and maybe ask them to spend more time on it? Either way, we do want to get useful feedback. We want to know, NASA needs to know why the reviewers evaluated it the way they did. So that's very important, and so we will work on that. I think, I had something else, but I lost. That's really good feedback, though, so thank you.
And I just want to put in a plug, when NASA, NOAA, NSF, I'm sure it's the same, when we reach out for you to serve on panels, please participate when you can. We cannot review the volume of proposals that come in without you. We rely on your expertise, and thank you for it, and really appreciate it. And please, please participate when you can. It's the only way we can all be successful in these reviews.
Thank you.
I echo Nikki, because NSF also has experienced a large volume of proposals these days, and we appreciate your help. And whenever you, agree to be part of a panel or review process, NSF really appreciate your service work. So thank you again for those who have participated in panel process for NSF.
All right, thank you. We are almost out of time, but I would like to see if we have question on the Slido. Maybe one more question.
Ooh, hard to decide. All of them are so good. I'll start with the first one that was voted higher. Private companies have asked scientists to validate their data products to sell to NOAA, etc. However, when they find out that they need to pay scientists, they seem to be surprised. How are you communicating to industry that we are paid partners?
Yeah.
No, yes.
And Noah, if you.
Yeah, Irfan, are you online?
I am online. So there's two ways that companies, or at least the way that NOAA evaluates commercial data. Oftentimes, NOAA does these data pilots where we actually procure sample data sets from our commercial providers and evaluate and assess the quality of the data. In that case, we actually reach out to the scientists to help us evaluate the data quality and assess. So that's one way. If the companies are going out directly to scientists, I cannot comment on that, but certainly within NOAA, we have a process where we engage with the research community to help us assess the data quality. In fact, that's something that I work very closely with our commercial data. And if people are interested, certainly reaching to our commercial data programs are there where there are capabilities to help them assess potential new data sources.
Okay, thank you. Hope that answers the question. One more, go ahead.
One more?
Yeah.
Okay. I used to think of NASA as doing discovery science. Your presentation implied it now does operational research. Is that interpretation correct?
No. We still do discovery-based science. We do discovery-based science that happens to have amazing applications, and both things are true. We appreciate our ability to do things that only NASA can do, to make discoveries that only NASA can, in environments that only NASA can get to, and that is where our foundation of our work is. It also happens to be that many of those scientific discoveries have application benefits and operational benefits, and we want to capitalize on those where those exist.
Okay. All right, thank you. So we are 3 minutes over. Thank you very much to our speakers, and also all of you guys for being here. So we have about 15 minutes of break, and then at 10 o'clock we resume our breakout sessions. Thank you all.